Hello, everyone, and welcome back to the second part of 12-2 Conditional Probability. So once again today we're finding the probability of an event given that another event has occurred. So probability of A given B. Once again, I want you to try all of these out. I want you to learn through what you get right and what you get wrong. So let us start with a warm-up. So using this table, I would like you to answer these 5 questions. Please pause the video, and when you are done, unpause so we can check to see if you got them right. Okay, so let's go over these answers. So the probability that the car is white, there are 2 white cars out of 22 total, part over whole. Remember, we like to simplify our fractions. Now, probability it's white and it's a pickup. There are 2 white pickups out of 22 total. Same probability as probability of white. Probability of a pickup given that it's white. So we can look at the probability, the white pickups over all of the whites. So 2 out of 2. We want to do the probabilities here. We can say the probability of pickup and white is 1/11th divided by the probability of white, which is 1/11 as well, and we still get 1. So either we can look at it by the frequency or probability of the intersection divided by the probability of just white. Now, probability of white or pickup. Okay, we talked a little bit about this in the first lesson. Okay, we have to count how many whites there are, there's 2 white vehicles. We count how many pickups, there's 8 pickups, and we subtract the overlap. So there's 10 cars that are white or pickups, but there are 2 that are overlapped. So that's how I get the 8 over 22. And then probability of white given pickup, I just want you to see that the order of the conditions matter. So there are 8 total pickups, and 2 out of those 8 are white. So really what the given statement is matters when we're looking at order. And today we'll keep exploring that, keep looking and seeing how to determine whether events are dependent or independent. So here's another table. It's actually probably the same table. Let R represent selecting a red vehicle and C represent selecting a car. We need to figure out whether R and C are independent or whether they're dependent. So I want you to try this out. Pause the video now, unless you want a hint, and if you leave the video unpaused, I will give you a hint. Okay, so here's your hint, if you'd like it, to test whether they're independent or dependent. Remember, if they're independent, the probability of a red given as a car has to be the same as the probability of the car. And I wrote that backwards. That is the inverse probability of red. So now go ahead and test that out if you're still not paused yet. Go ahead and pause. And here we go to look at the answers. So like I said in the hint, we need to test if the probability of red that the car changes the probability of just picking a random red vehicle. So probability of red, any red vehicle, is 7 out of 22. And the probability of red, given that its car, is 5 out of 11. So knowing that I picked a car, it is more likely that it's red than just any given vehicle. I can do the same thing for test car for red, and notice that these probabilities aren't the same. So a red vehicle and selecting a car are dependent. because the probability of the red vehicle is changed when we know that the car is chosen. Okay, probability of red doesn't change just when the probability changes when I say, let's pick a car. And the probability would change when I said, hey, let's pick a truck. So in this case, and in most cases, when we're buying vehicles, the color is dependent on the vehicle style. No one picks a pink truck, but lots of people pick pink sedans. Okay, white is a very common color, or black is common color for a van. I don't see too many red vans. So that's dependency. So in this case, red and car are dependent upon each other. Either one of these would have shown they're dependent. We just showed both. Now, this also works with companies. Okay, in this case, we got selling mobile phones. So I would like you to read the problem, try it out, and answer this question over here. Which product would you say has the most successful marketing technique? I want you to justify your answer. So go ahead, pause the video. When you're ready, unpause it, and we will take a look. Okay, so we are looking here to see which one is the most successful marketing. As in, out of the people that search it, which ones buy? So I want to find the probability that they buy given that they search. Because obviously, if not a lot of people buy your product after seeing your marketing, not super successful. So in this case, I look at each one and see the probability of buy given search. And remember, the probability is we take the probability of the intersection and divide it by the probability of the second part. So probability of buy and search. The probability of buy given search, in this case, is the probability that they buy and they search, or the probability of who just searches. So what this is saying is about 34% of people that this product W was 34% successful in marketing. Product X, which was the most successful, was 44%. And then we have the other 2%. And we would say that X is the most successful marketing technique. And now we got another one to practice. Okay, and this one's actually strangely relevant to today's scenarios. Okay, where there's a dependency, okay, on whether a test, if I test for, in this case, strep throat, whether the test is accurate or not. So I want you to read this problem through, test it out, and once again, when you're ready, unpause the video, pause it whenever you have a question, or you stop and you say, hey, this is enough information to get me to the finish line, and we'll get there together. So an article in this Journal of the American Medical Association, 1997, reported that when people go to the doctor's office with a sore throat and think they might have strep throat, 30% actually have strep throat. It noted that a current test was 80% accurate if you have strep and 90% accurate if you do not. What's the problem? What's the probability that a person who receives a positive result from this test does not have the disease? So what we are looking for here is the probability that they don't have the disease. So we can call it disease not, okay, depending on what variables we're going to use, given that they have a positive test. So that's what you're calculating. So again, pause the video if you need more time to try this one out, but that's the first hint. Now here's where we're going to look at this problem. Now I used S for instead of D. So S has strep throat. T is positive test. Now I don't want to use N for negative test or N for not strep throat, so that's why we use the complement symbol. So S complement is not have strep throat, not strep throat. And T complement is test negative. So test negative means that the test shows you don't have it. It does not talk, none of these talk about whether they're accurate or not, and that's what we got to use the probabilities for. So the probability that they have strep is 30%, which means the probability that they don't have strep is 70%. Okay, now it also tells us that it's 30% is 80% accurate if you have it. So the probability that you test accurately for it, if you have it, given that you have it, is 80%. And the probability that you get a negative test, given that you have it, is 20%. Now, this is a very bad case where if you have it, you want to test positive for it, you want it to be accurate. This is an accurate case. This is inaccurate. Now we can write out the probabilities for the other case too. Okay, so probability that you test negative for it, given that you don't have it, this is accurate. Another accurate test is 90%. And the probability that you test positive for it, given that you don't have it, is 10%. Now, some of this information is going to be useful, some of it might not be. But I like to write down all of my probabilities when I get a problem. Okay, now the two on the left are good cases or accurate cases. Okay, positive test, have strep, negative case, don't have strep. This case is called a false negative, which is very bad. And this is called a false positive, where you test positive for it but don't actually have it. Now, I want to know the probability they receive a positive test and they don't have it. So I want to find this variable right here. Now, once again, we have a lot of other variables we could put in the equation. So the probability that they test positive, given that they don't have it, is 10%. We don't know the probability that they test positive of a random person testing positive and not having it, but we know that the probability of a person not having strep is 70%. So we can take this and multiply both sides by 0.7 and get the probability that they test positive and don't have strep is 7%. So 7% of the people have a false positive. Now, conditional probability, to wrap it up. It's the probability of an event B occurring given that we already know that probability A has occurred, which generally affects the overall probability if they're dependent. So if they're dependent, the probability of B given A is going to be different than the probability of B. So if they're the same, which shows it over here, if probability of B given A equals the probability of B, the two events are independent and A is not affecting how B functions. Most of the time, lots of events are dependent, where one event is going to change the likelihood of another event occurring. And that is the definition of conditional probability. Now go ahead, try out the homework, ask your teacher for questions, try the exit ticket, and you will understand how conditional probability works.